Atomic radius. Here you can see a nucleus. Inside the nucleus, we have protons and neutrons, and here we have the electrons. Now, the distance between this nucleus and the outermost electrons of this outermost shell is actually called as the atomic radius. Now, here, the atomic size of an atom depends upon the atomic radius. In our today's video, we are going to talk about what is atomic radius, what are the factors that affect on the atomic radius. Moreover, we are going to learn about the trends of atomic radius in the period and in a group. What is atomic radius? The size of an atom is the average distance between the nucleus of an atom and the outermost electronic shell or the outermost electrons which are present in the last shell. The size of an atom depends on its electronic configuration. Say for example, here we have 1s2. If the electronic configuration of an atom is 1s2, it's very clear that the size of the atom is very small. And if the electronic configuration is like 1s2, 2s2, 2p6, 3s2, now this time it's very clear that the atomic radius or the atomic size of this atom is big. So this is how the size of the atom or the atomic radius depends on the electronic configuration. Now here we have some factors that affect the atomic radius. The greater the nuclear charge, the less will be the atomic size, because increase in nuclear charge increase nuclear force on the valence electron. Here we know if the nuclear charge is greater, what will happen that the nucleus will attract the outermost electrons or the outermost shell towards itself with more strength. Due to this stronger attraction, what happens that the size of the atom starts shrinking, the size of the atom get contracted. So this is what happens when the nuclear charge is greater. When the nuclear charge is greater, the size of the atom or the atomic radius gets smaller. If the number of shells are greater in the number, then the atomic size is also greater and vice versa. Now what happens here, if we have an atom and in this atom we just have two shells, and if we have another atom and this time this atom has three shells, so it's very clear from the diagram also, the one who has less number of shells is smaller in size and the one who have more number of shells is larger in size. So the size of the atom, the atomic radius also depends on the number of shells. More number of shells means a larger atomic radius and less number of shells means a smaller atomic radius. Shielding or screening effect is directly proportional to the atomic size. More shielding effect means greater atomic size. If you can see an atom here, these are the number of shells and these are all the electrons which are inside the shells. The electrons present here are acting as a shield for the outermost electron. Now the attraction of this nucleus towards the outer shell becomes less as compared to this atom. In this atom, we only have one shell. It has less number of electrons. It means less shielding effect. So more shielding effect means greater atomic radius, and less shielding effect means a smaller atomic radius. So this is how shielding effect affects on the atomic radius. Here we have trends of atomic radius in periodic table. Atomic radius across the period. As we move left to right in the periodic table, atomic radius decreases. Atomic radius decreases because here the number of the shells remains constant, but the atomic number increases. Due to that, number of protons are also increases and number of electrons are also increases. When the number of protons and number of electrons both increases, the attraction of the nucleus towards the outermost electron increases, due to which what happens that the size of the atom, the atomic radius gets smaller. We can understand this concept with the help of an example. Here in the period we have lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. Here in all these atoms we have constant number of shells. Now let's compare this lithium and this carbon. In the lithium, we have 3 number of protons and we have 3 number of electrons. In this carbon, we have 6 number of protons and we have 6 number of electrons. Because this time in the carbon, we have 6 number of protons and the 6 number of electrons. So it's very obvious that here we have a greater nuclear charge. Due to the greater nuclear charge, the attraction of this nucleus towards the outermost electron is greater, and due to this, the size of the atom will get smaller, it got shrinked. But here in the case of lithium, because we just have 3 number of protons, so as compared to the carbon, we don't have much nuclear charge. What will happen? The size of the lithium will be greater as compared to this. So this is why we say when we move left to right in a period in the periodic table, the size of the atom or atomic radius decreases. Atomic radius down the group. The atomic radius increases when we move up to down in the periodic table. Because this time what happens that the number of shells increases, shielding effect increases, and the atomic number also increase. Now let's understand this with the help of an example. Here, at first we have hydrogen, then we have lithium, then we have sodium. In hydrogen, we only have one shell. In lithium, we have 2 number of shells. And in sodium, we have 3 number of shells. As you can see here, now the number of shells are also increases and the atomic number is also increases. And most interestingly here, the shielding effect also increases. Let's compare this lithium and this sodium. If we compare them according to the number of shells, here we just have 2 number of shells and here we have 3 number of shells. Due to these number of shells, we have a greater atomic number. Here we have 2 electrons and here we have 10 electrons. Now between the nucleus and between this outermost shell, we have 2 number of electrons here, and between this nucleus and this outermost shell, we have 10 number of electrons here. So here we have less shielding effect and here we have more shielding effect. Due to this shielding effect, this attraction of nucleus towards the outer electron or the outer shell becomes very less, and due to less shielding effect here, the attraction of this nucleus towards the outermost electron becomes more. So that is why as we move top to bottom in the periodic table, the size of the atom increases gradually. So yes, this is all about our today's lesson. If you want more such videos, please don't forget to subscribe. Thank you very much.